Good morning, everyone. This week we are learning about gases, and you can find this lesson in chapter 11. The big idea is that the gas laws describe mathematical relationships among the pressure, temperature, volume, and quantity of gas. Now, we've already learned temperature from chapter 2 in our textbook, and as we know, temperature can be expressed in three different units of measurements, namely degrees Celsius, degrees Fahrenheit, and Kelvin. Now, for our mathematical calculations in this chapter, we're going to need to do a conversion of temperature, and that is from degrees Celsius to Kelvin. If you have a problem which gives you degrees Fahrenheit as the temperature unit, you also need to convert that into Kelvin. Another quantity that is involved is the volume. The volume can be expressed in liters, milliliters, cubic centimeters, cubic meters, and many others. The quantity of a gas is simply grams or moles of a gas. Now, one quantity that has not been explored in this class is the pressure. And the pressure is defined as the force per unit area. We have that in here in section 1, which is gases and pressure. And the main idea is that the collision of air molecules generate pressure. Okay, so pressure is force per unit area. The letter notation that we use for pressure is P. F is for the force, and then A is area. Now, in our textbook, we have this illustration. This is figure 1.1 on page 349. And here we have first a force of 500 newtons. The area of contact is 325 centimeters squared. For the other two pictures, the forces are still the same, 500. For the second picture is
only 13, and the third one is 6.5 cm squared. Now, using our equation for the pressure, okay, so let me just move this in here, and pressure P is equal to F over A. F is the force and A is the area. So for letter A, P is equal to 500. I'll put a dot right here to make this three significant figures, and N stands for newtons. And that's the unit for force. Divide this by the area, and the contact area is 325 cm squared. So, you divide this, use your calculator, and you will get 500 divided by 325 equals 1.538461. Okay, and go ahead and round this to three significant figures. So we have 1.54, and then the unit is Newton over centimeter squared. So you just have to copy this two units. Alright, so another example. For the second picture, the area of contact is lesser. So, again, pressure is equal to force over area. The force is the same. It's still 500 newtons. Divide that by 13.0 cm squared. Again, I'm just adding a 0.0 because I want three significant figures for the final answer. So go ahead and divide 500 divided by 13.
Okay, so the answer is 38.46. Okay, and then we'll round this to 3 significant figures, so that makes it 38.5. 38.5 Newton per cm squared. Letter C. Again, pressure is equal to force over area. So 500 newtons divided by 6.5. So the contact area for this is even smaller. It's only 6.5 cm squared. All right, so let's have our calculator. 500 divided by 6.5, and we get 76.92. Now here, as you can see, we have 500 with a dot or with a decimal. That is 3 significant figures. The 6.5 here has 2 significant figures. So how many significant figures are we going to show in our final answer? Okay, remember that should be the lowest number of significant figures, and in this case it is 2. So go ahead and round 76.92 into 2 significant figures, and so we write 77 newtons per cm squared. All right, so that's all for the calculation of force. Please go over the lecture notes that I posted, and we have in there also an example on how to solve for the force using the given mass and the gravity.